Hello, today I'm gonna talk about the light harvesting complexes. But before that, let's take a look to this side. In this side, we have chlorophylls, which are light absorbing pigments. We also have secondary light absorbing pigments or accessory pigments, which are called carotenoids. Carotenoids are important because they are capable of absorbing light at wavelengths that these chlorophylls cannot. So it's like a supplementary light receptor. I see it like a complement for chlorophylls, and I put a ring because it's an accessory pigment I associate it with jewelry. Okay, so we have these pigments absorb light. So what is in the light? In the light, actually, what they're absorbing, it's called photons. So photons stand for a quantum of light. And quantum means the ultimate unit of energy. So let's say we have a chlorophyll that is absorbing the photons from the light. And what this is gonna do to the chlorophyll, it's one electron of the chlorophyll is gonna get excited thanks to the photons. Furthermore, before going to the light harvesting complexes, we need to understand that these type of pigments can be arranged in something called photosystem. And actually, all the pigments associated with a photosystem are capable of doing this, absorbing the photons. However, not all of them are capable of transducing the light into chemical energy. Actually, there's a special chlorophylls that do that, and they're associated with a photochemical reaction center. So the other pigments, what they actually do is serve like an antenna. Okay, now let's go to the light harvesting complexes. So these light harvesting complexes are full with these chlorophyll molecules. There are also chlorophyll binding proteins, and they are different from the free chlorophyll. They are different in a way that when this process happens, the process in which the electron gets excited, like this, is gonna pass the excitement to a neighbor electron. Like you see in the animation, it's gonna pass until it reaches the photochemical reaction center, which is that one capable of transducing the light into chemical energy. So all this process is called the exciton transfer because you're passing the excitement of each electron. So now that we have like that concept, let's talk about why this is important. So as you see, plants cannot move. And during the day, during different seasons, the intensity of the light, the wavelength of the light changes. So the plant had to, has to have a mechanism in order to adapt to these different lights. Okay, so here's one of them. So we have our light harvesting complex 2 that serves as an antenna. It helps to absorb the photons to either the photosystem 1 and photosystem 2. So all the photons that it collects per se are gonna go to the reaction center of either photosystem. Okay. So here's what happens when there's a different type of light or different type of wavelength. So as for photosystem 1, okay, no, you know what? Let's just start with photosystem 2. I think it's gonna be easy. So photosystem 2, when there's an intense light on a blue light, it's gonna produce so many of the plastoquinol. Uh, and the amount will be so much that the photosystem 1 will not be capable or oxidizing this molecule. As a result, the increased amount of plastoquinol is gonna activate the phosphorylation of light harvesting complex number 2. So what is it gonna do? That by being phosphorylated, is gonna move to this side, and it's gonna help the photosystem 1 in the absorption of photons, so it's capable of keeping up with this huge amount of plastic quinol. The other way, it's also a type of regulation. So let's say instead of having an intense light, you have a less intense light, like a red light. So photosystem 1 is gonna be capable of oxidizing this molecule that photosystem 2 cannot keep up with it. So the opposite is gonna happen. There's gonna be a dephosphorylation of the light harvesting complex 2. So instead of providing the photons for the photosystem 1, now it's gonna provide it for the photosystem 2, so the balance can be regenerated. So this is all for my part. Thank you.